Okay, so let's start with this paper from the web conference published in 2018. Okay, the name of the paper is CHIMP, Crowdsourcing Human Inputs for Mobile Phones. Okay, so the paper is pretty interesting, as you will see as we discuss it in this roughly half an hour kind of video, right? So the paper has been published by these places: Polytechnic University of Catalonia, University Catholic de Louvain, Telefonica Research, AT&T, University of Alabama at Birmingham. So quite a collaborative study in that sense. Okay. Okay, so let me sort of introduce the idea. So first of all, we will try to understand the different parts of this name itself. What is crowdsourcing and human inputs for mobile phones? Okay, what do you mean? Okay, so paper is around how to test mobile phone apps. Okay, so when you create an app, you want to sort of stress test that app before you want to release in the market. Okay, and the paper is around that. Now, of course, to test that app, you can give it to your friends, and they can test it for you. But hey, how many friends do you have, right? I mean, and how many of them would want to give their time to you to actually stress test that, right? So therefore, oftentimes what people do is to do crowdsourcing. So you actually pay people to actually test your app, right, by making the app available to them. Okay. Typically people have been using crowdsourcing platforms like Amazon Mechanical Turk, Crowdflower, and so on, right? So so we discussed those crowdsourcing platforms in our crowdsourcing in our web mining module, right? But then there are these kinds of problems, challenges around mobile app testing using crowdsourcing platforms, and which is what this particular paper is about. Okay. So now many times you don't want people to test your apps. Rather, you want automated software to test your apps, and that automated software is called monkey scripts. Okay, so mobile app development with monkeys. Now, while developing apps has become easier, testing and characterizing them remains challenging, right? Because of a dearth of tools for large-scale testing and measurement of mobile apps, right? So de facto standard app testing technique is to use these monkeys or automated scripts, actually, right? So so Selenium is basically one of the popular tools so as to write these monkey scripts in that sense, right? So monkey is a simple tool that performs random, of course, partially configurable inputs operating under the assumption that a million monkeys tapping on a million touchscreens will eventually expose faulty code. So the idea is that they try all possible combinations of inputs that are possible in this game. So they play a game, really, right? And then the hope is that since you are running like millions of such game instances, therefore you will catch any possible bug that might be present in the entire mobile app or mobile game, right? In that senses. Okay. But monkeys, like Selenium scripts, have issues. So what are the issues? Prior work has shown that monkeys are not well suited for certain types of inputs. For example, filling out forms. So to fill out forms, then usually you require some logical input to be filled in. Normal users would fill in logical input, right? Monkeys are not really good at doing that. Okay. Also, monkeys' inputs don't reflect those of actual app users. So if you're trying to test the performance of your app, now actual users may not really touch a feature which is really which takes a lot of RAM or a lot of CPU and so on, a lot of compute power. But monkey scripts will show you that, hey, 10% of these scripts basically failed because it required a lot of RAM and so on. Okay, so actual damage may be very small, but monkey scripts may make it feel very large, or the other way around. Actual damage may be very large because most users actually touch a feature in the app or in the game, which takes a lot of RAM and compute. But since you are using monkeys, it's all random. Okay, so it basically doesn't show up that nicely, that in a very representative way when you're testing using monkey scripts. Okay. So the issues with monkeys, more issues, right? So while real users focus on the part of the screen where gameplay actually happens, monkeys make no distinction and spread their efforts across the entire UX, entire user interface, right? So while this might have some advantages, if you want to explore all the code paths, if that is the desired outcome, but it is very much a problem when looking for example, the way an app's users access the network, or understand how users will navigate through the entire app, right, through options, menus, or evaluating a change in the functionality or the UI. right? So when you want to because given an app, not every feature is used uniformly, right, by the user. Some features are going to be used more frequently compared to the others. And if this frequency analysis is your goal, monkeys are not the solution, right? You have to have people actually test your apps, right? So this figure actually shows you this particular frozen bubbles game. So essentially, this is how human input looks like, but this is how monkeys inputs look like, spread across the entire screen without any care about. So humans usually tend to focus at the center, right? But monkeys don't, right? So that's the problem, right? So we still need humans to test the application. So more or less what I've done is to sort of convince you that, hey, humans are really required to test these applications. Now, while large-scale human testing is mostly achievable, so if you want to get it done, proper testing done, you might want to do it at large scale. And giants like Apple, Google, Facebook, Microsoft, Amazon can surely do that because they have that kind of money. But smaller developers do not have thousands of users to do A/B testing, right? So these giants, not just they have money, they also have nice large user base, right? And what they usually do is to do A/B testing, in the sense that a small percent of users is chosen to do test, right? And they basically just put out these new apps to these small set of users, oftentimes in a beta test mode and so on, and get the testing done, okay? But small developers do not have access to such a large user base. They can't do A/B testing really, right? So therefore, and they also do not have app stores where they can actually publish their apps and make users use them, okay? So users, and again, if users have to sort of test these apps, they also need to install these apps, right? Now, not everyone wants to install these apps, especially when they know that it is being tested out, right? So this is all the reason why the authors have put out this paper, CHIMP, to assist human testing of Android apps. Okay. So the idea behind the paper is that the system called CHIMP actually enables quick collection of human inputs for mobile apps. Okay. CHIMP actually runs apps on a server, streaming them to a browser for real users to interact with. So the users don't really need to install their apps or those apps on their machine, but it runs on a server and then just streams it on the browser. The user just needs to interact with the browser so as to test the app. Okay. While users test the apps, CHIMP collects a wide range of data. User interactions, network traffic, runtime traces, performance, etc., as well as explicit user feedback. So of course, if the user is giving a feedback, sure, take it, but it also keeps tracking these other kinds of things like network traffic, interactions, and so on. Okay. App developers or researchers can use CHIMP with apps they want to test and specify the data they want to collect via campaigns, which can be nicely configured inside CHIMP. Okay. So if you want to particularly get a kind of data, you can actually configure that in this system. Right. CHIMP offers integration with Crowdflower. So Crowdflower is a crowdsourcing platform, along with user validation techniques to quickly provide large, trustworthy data sets around mobile app testing. Okay. So I will not go into too much of detail, but previously people have tried some work on automated app testing. Okay. So in fact, automated testing can be considered a search problem where the objective is to explore the largest possible set of app functionalities within a defined time span. So the idea is that you have limited time span, and in this time span, you want to figure out as many bugs as possible in the code, right? In the app, in some senses. So of course, the idea is to try as many app functionalities as possible, and as a byproduct, figure out any bugs. Such an exploration is usually measured in terms of code coverage. So the idea is, what would you call as a good software which is testing your app, right? So a good testing of the app basically should be such that it actually covers the entire code, right? Which basically makes the app function. Okay. So it is a number of lines of code in the target app that the test exercises. So good tests are those which can actually cover the entire code base that has been written for the app. Right? So there are some papers, when I write these references like that, at the end there are these references which I will go over, very quickly show you. So if you want to read more about, automated app testing, you can actually read this nice paper. It sort of it talks about 14 different testing tools grouped into 3 categories. Okay. So different kinds of tools which have been proposed for doing app testing. Okay. These 3 categories are random, model-based, and systematic app testing tools. Okay. So a little bit of what these mean really, right? So random tools are best exemplified by the official Android monkey. So there is, this official Android monkey script which Android has made available. So these random tools it is one of those random tools. So they're called random tools because they amount to a blind brute force search through the app being tested. So it's basically exactly the behavior is like this, very randomish behavior. Okay. The random testing tools are reasonably easy to use and often provide pretty good code coverage. Now, they provide good code coverage mainly because they are random in nature. They don't really focus on a particular functionality, but focus equally on all kinds of functionalities in the app. Okay. Now, model-based. So model-based tools view mobile apps as a finite automata. So if you remember from theoretical computer science classes, which you might have had at some point, there are these finite automata in the sense you can describe the functionality of an app using a state transition chart in some senses. So where the user actions trigger transitions between states. So each state, you can think of it like a state in the game. And if the user does an action, the state of the game changes to another state and so on. So finite automata basically is such a state transition diagram with limited number of states, right? So models can be extracted considering the sequence of function calls. So if you think of each of these actions as calling a function and so on, you can then create a call graph model, so to say, which basically says which function was called after which one and so on. Okay. The user interface layout and the interaction between components. So all of these kinds of things can actually be used to create models. After the models have been, are built, testing corresponds to exploring the space of the state machine, terminating when all state transitions have been checked, right? Have been discovered. Okay. So those are model-based methods. These are all previous methods. So we'll spend, we'll quickly glance over them and then move on to CHIMP actually, right? So the third kind of tools, previously proposed tools, have been systematic exploration tools, which are more complicated and use things like evolutionary algorithms in an attempt to produce inputs that improve the code coverage. Okay, so that's that. They use evolutionary algorithms. So evolutionary algorithms are usually very useful when you want to explore a very large space, and you have a way of measuring how good your current candidate is, but you don't have enough time to explore the entire space. Right? That's when evolutionary algorithms are very useful. Okay? And people have tried to use them as systematic exploration tools for app testing in that sense. Okay? So all these tools have strengths and weaknesses. Each of them have their own strengths and weaknesses, but ultimately, so this paper actually finds that no tool is superior than the other. So they are all, some of them are good at some things, others are good at other things. Right? Indeed, monkeys often beat more sophisticated tools in terms of code coverage. So automated tools, these ones, the random tools, basically oftentimes beat the other ones, the other two types. Okay. So they share, however, an important limitation that they are all stress test tools only. So you just try to do stress testing, and there is no actual user behavior which is coming up in these tools. Since no real human input is synthesized, no information regarding actual human behavior is collected. So if you put this tool in the real world, how would people actually start using or this app in the real world? How would people start using this app? That kind of information you just can't get using any of these methods because these are all automated stress test methods. Okay. So there are also tasks that might either be easier for or even require real humans. For example, login screens, filling out those forms, playing strategy games and so on, which just can't be tested by writing automated code. Okay. So that is why basically in this work, these guys, these authors actually focus on CHIMP, which basically involves some crowdsourcing, some human inputs as well. Okay. So now crowdsourcing for app testing is not like very new. I mean, of course, it has been tried earlier. Especially these two particular systems, iOrg and Mobilizer. But again, the goals of these systems were pretty different. So iOrg is basically for web quality of experience measurements. It's not to do with mobile apps at all. And Mobilizer, of course, has to do with mobile apps, but it's a platform for measuring network measurements in a mobile app. It's not for basically app testing as such, but just figuring out how much network or what kind of network usage this particular app has when you install this app. Okay. So now this particular thing more or less shows you the architecture of CHIMP. Okay. So when a user is basically trying to do app testing, so essentially imagine that you're doing app testing. All you need to do is to log in on the browser. You don't really need to use a mobile phone. You don't need to own a mobile phone. Okay, you just need a browser. You go log in, okay, and you're shown this screen. Okay, in fact, you're not shown the entire phone screen. The part of the phone screen, the major chunk of the phone screen is sort of taken, and it is relayed to the network, to the browser. Okay, so what you see on the browser is a part of the phone screen. Okay, so CHIMP is made available as a web application. So it's not a mobile application. In fact, it's made available as a web thing. So you can load it up on the browser and check. Right? And users interact it via the web client. So a web client, any browser you can use, just interact with it. Within the web client, they interact with an Android virtual phone. So of course, there is a virtual phone on which the app is running. And what is going on is that the image from the virtual phone is sort of streamed back to the user so that they can interact with it. Right? So where mouse clicks and drags get translated into taps and swipes. So if you do a click and you do a tap, it's sort of and you do a drag, that's sort of translated to taps and swipes on the mobile phone. Okay. So challenges, of course, multiple challenges when building this kind of a framework. So web client workflow. So essentially, how to organize and present tests to the users. So when you basically have multiple apps to be tested, how do you present them to the user, right? Selecting an effective means of virtualizing a phone for users. So basically, of course, at the back end, they actually use an Android image. So if you know all of these operating systems, an instantiation of them is called an image, right? And all of them work. These games are being played on a virtual Android image, and somehow these virtual Android images need to be transferred back to the browser. How do you do all that? Right? So supporting a multi-user experimentation platform. So if you have like a single mobile phone image, you can only transfer it to one user. So if there are multiple users who are trying to access apps on this phone, do you need one image, or rather is using a single image, how much can you scale? How many users can actually test using the same image, right? So that's the other question. Collecting useful data for experimentation, so for experimenters. So in the sense, further analysis if you want to do, what kind of data you can collect and how do you collect all that data, right? So that's also a challenge to be addressed. Okay. So this one basically shows you an architecture diagram of how it all works. Okay. So there is a virtual machine on which the Android image is running. So from that, some part of the screen, major part of the screen is taken, and it is actually showed to the user. Okay. At the back end, it's basically running an Android x86, and using KEMU for virtualization. Okay. So streaming is going on here, which basically takes part of this, part of the virtual machine state, and actually shows it to the user. Okay. System logs need to be written using some simple monkey scripts, and also so essentially we will also see that why Google Play is required. Of course, that's required, or rather crawler on Google Play is required to crawl new apps and make them available for testing. Right? So crawl the apps and make them available for testing. PostgreSQL is basically used to store the data, store any kind of metadata or any kind of measurements, and collecting all kinds of useful data that's basically stored in PostgreSQL and so on. Okay. The controller sort of controls the flow, the entire flow. So in the sense, which particular app is given to the user for testing, how much time does the user, spend with the game or the app, and so on. Right? So this one basically shows more like the time diagram, the sequence diagram. So when a user sort of starts to interact with the app, with this particular CHIMP software, okay, the user needs to first take a simple test. Okay. Just a little bit of a form so as to understand what is the demography form in some senses, so as to understand what the user's background is and so on. In the meantime, actually, the virtual machine is booting up so that it can actually run the APK, the app itself, right? So the Android platform app. Okay. And then the instructions are shown to the user. So basically, the app is launched and the instructions are shown as to what you can do with the app, right? So once the user starts interacting with the app, all kinds of interactions and data produced is stored in PostgreSQL. But once that gets done, after that, essentially, an experience form is shown to the user to get explicit feedback from the user as well. Okay. So if the app broke down in the middle, then tell about that and so on. So you basically get all of that. And as the user is filling this experience form, basically the image is being cleaned. So in the sense, you're done with app testing. Clean the image, remove that app from the image, from the Android image. Okay. So this thing is cleaned, and then a new APK is loaded so that the user can get started testing the new app. And this is where the new app is launched, and after the experience finishes, again the user is shown another experience form, and then the user always has a choice to actually start testing the new app or basically shut down the virtual machine. Okay, so done with testing, that's when the virtual machine or the virtual phone is sort of shut down. Okay. So that's basically it. So so in the next few slides, I'll sort of go over more details of this CHIMP architecture. But this is how the CHIMP has been designed. Very nice architecture for sort of crowdsourced app testing for mobile phones. Okay, good. Okay, so the web page presented to the user is composed of a streaming area replicating the content of the virtual phone's display, and a control area allowing the user to issue specific commands to the system. So this one is like the control area where the user can say, hey, I want to move to the next app, or I want to stop the thing, and so on. Okay. The number of actions that the user must be taken before the user can actually interact with an app. So a session is defined as the entire set of actions a user takes in CHIMP. Okay. And the session starts when the user visits CHIMP's homepage and says, take a test. Okay. A welcome message is presented, including a form to get the demographic data. So here is where we are getting the demographic data. Right? While the user is actually busy filling out this form, basically the virtual phone is booted up. Okay? When the virtualized environment is ready, users can actually press the launch button and actually start playing around with the app. Once the instructions are dismissed, users interact with their first app. Since CHIMP allows users to interact with different apps, we partition each session into multiple steps, one per app. The control area now lets users navigate through steps via next app or finish buttons, right? So they can choose to play with the next app or finish the session. Okay. So after clicking one of these two buttons, the experience feedback questionnaire is presented. So this kind of an explicit feedback form. Okay. If the user pressed next app, the previous app is removed and the new app is loaded into the virtual phone. After filling out experience feedback, the user can actually start interacting with the new app, and the user says finish. The virtual phone is shut down and the image is sort of restored back to the pool of empty images. Right? So that's that. Now, the Android virtual phone which is used, this is the core of CHIMP, the core hardware piece. Right? Built around the virtualization of these Android mobile devices. So of course, one has to provision an Android mobile device and then do virtualization on top of it so that they can take the thing which is being shown on this machine and stream it back to the browser. Okay. This is accomplished by instrumenting these virtual machines running the Android OS to provide the user with the Android virtual phone called the AVP. Okay. To maximize this app compatibility, CHIMP should be able to execute ARM instructions. ARM is a kind of a computer architecture, right? So as to support apps that use native binaries, also support OpenGL. So OpenGL is very important for games. If you don't know OpenGL, just try searching for it. So it's a very popular library for gaming, right? And offer lucid interactivity. So very fluid interactivity, very nice interactivity should be allowed. And that is what are the requirements. So therefore, these guys try to look at various kinds of options. So Android emulator options. So you have to sort of emulate this entire virtualized mobile phone, right? So Android emulator, KMU, and so on. And they finally sort of chose the KMU plus Android x86 to execute the Android operating system, right? So KMU also comes with this streaming kind of thing called VNC, and which is what they use to stream the information from this virtual phone to the browser screen. Okay. Now these campaigns and what does this controller do? Right? We actually saw a controller sitting out here. What does this controller do? Okay. So user sessions are grouped into various campaigns, and a campaign is nothing but a set of parameters that includes the target set of users, how many apps to show to the users, and which ones to show, what kind of feedback to collect from users, and so on. Okay, so that's basically a campaign. You can think of it like a experiment that any user of this system would want to perform. Okay. The different components of CHIMP are orchestrated via controller and a scheduler. So it's not just that there's a controller, there's also a scheduler which sort of control how these components work in the entire system. Okay. So the controller tracks events which are issued by the web client control area. So the user says next app, so controller looks at that, right, and therefore schedules the next app. triggers job scheduling and so on. So for example, when user says next app, basically it tries to retrieve data from the virtual phone and the web client and prepare the virtual phone for the next app and so on. Right? So CHIMP also uses something called a sidekick, so as the job processing framework, so which in turn uses Redis to back the job queues. So remember, when the users are giving out these messages, for example, if the user is clicking and dragging and so on, these are all messages which have to be transformed, which have to be sort of propagated back to the mobile phone image. Right? So all of those messages are actually handled using the Redis messaging queue, right? And the sidekick is actually the job processing framework which is used in the background, right? If you want to read more about say sidekick, look at this reference paper on it. Okay. So CHIMP scheduler makes use of 3 kinds of queues. Now there are 3 kinds of messages: high priority messages, default, and low priority. Now, high priority ones are the ones which are system critical. So, for example, extracting code coverage metrics and so on. Default queue basically jobs related to user experience. So, like if the user did a drag or a click and so on, a virtual phone booting shutdown and so on. Low priority ones are the ones reclaiming resources like timeout sessions, post processing of the campaigns for reporting purpose and so on. So that's basically various things. Now, what all does CHIMP collect? So CHIMP collects a whole bunch of data, and again, I will not go over each of those, but we'll give you a gist of what kind of data CHIMP collects. Yeah. So, 6 types of data in general, right? 1, user interaction. So if you're doing any events like hovering your mouse over something, clicking somewhere, or dragging and so on, all of that is collected by CHIMP. Okay. User feedback. So while the virtual phone is booting or the next app is booting up, users are asked to fill this demographic form and also asked to fill the explicit feedback form. All of those data is also collected, of course, by CHIMP. App data. So at the end of the session, CHIMP retrieves the execution history of the app. It can be obtained using the logcat command on the virtual phone to identify exceptions or crashes that might have happened when the user was interacting with the app. Similarly, dumpsys is yet another command which is used to collect app's resource consumption. How much CPU memory did the app use over the entire interaction time period? So all those app-related system metadata is also collected by CHIMP. Runtime data, so in the sense via method tracing, so code coverage analysis about when the user interacted, what part of the code did the user touch in the entire interaction. Right. So it also allows automated monkeys whose inputs can be used in conjunction with humans. Of course, this system, the CHIMP, is meant for humans, but it can also be used by monkeys, monkey scripts. Right? So one can also still write monkey scripts and use CHIMP on it. Right? Network data, so CHIMP uses TCP dump and other kinds of network commands so as to figure out what kinds of network sockets were opened or closed while playing this game or interacting with this app. System data. So lastly, a module that monitors both the whole system health of the entire virtual machine, right, of the entire Android virtual machine, as well as the connectivity toward each individual user, web client, and the associated virtual phone. So remember, 4 or 5 or more users might be using the same virtual phone. So the system data is about collecting all possible kinds of such data. Okay. So lastly, let's just talk about a few experiments that these guys did. So they actually deployed CHIMP on a server with 128 GB RAM, 130 Mbps disk speed, okay, and 7,200 RPM hard disk, right? So it was quite a strong system, 2.6 gigahertz machine, so 2.6 gigahertz Xeon CPU, right? So, and they put up an Android x86 image on top of it, which by itself requires 1.6 GB RAM. So remember, if like 5 users are sort of using it, they would require 1.6 into 5, like 8 GB RAM just to load the image, just to load the Android image that they are interacting with. So they crawled top 500 apps per category from Google Play Store, and that is why we basically needed this kind of a crawler, so as to crawl these top 500 apps from Google Play Store, okay, and then retrieving so many unique apps. Okay. They also recruited about 1,000 users on Crowdflower because you need users to actually start using these apps. So recruit them, and VMs could be loaded in RAM or from disk. So the virtual machines, of course, if you think this is too large of a RAM, maybe they are on the disk, and they can be loaded in RAM or from disk. Right. So how many real users does CHIMP support? So this sort of chart shows you some stats about their experiments. So 71% of the apps were installed and launched fine. So of these apps that were downloaded, so many unique apps, they tried to install them automatically, right? Because as part of the thing, you have to basically automatically install this app, right, before the user can actually start testing it. Okay. they found that only 71% were installed and launched fine. The remaining just couldn't be installed. Okay. But the good part is that official Chrome-based mechanism only supports like about 59% of these apps. So CHIMP was at least better, that they could actually install seamlessly many of these apps. Okay. Now this chart basically shows the consumption in terms of CPU, disk, and memory. When for the first row shows when the VM was in RAM. This one basically when the VM was so rows are HDD and RAM. So this is for disk. So when the VM was in disk, this one when the VM was in RAM. Of course, if the VM was in RAM, disk usage is very minimal. So on the x-axis, what do you see? You basically see how many concurrent users are actually using it. Right? On the y-axis, you see utilization. So essentially, of course, as more and more people are using the machine, the utilization increases. Right? Disk basically says that only 4 people could actually use at the same time concurrently, right? Because if you store the VM in the disk, basically more or less it reaches about 100% of utilization. Right? RAM being used is too small because hey, the VM is stored on the disk. In this case, RAM being used is high and disk usage is small because the VM is in the RAM. Okay, so that's that. Okay, and here are a few results with respect to how many crashes happened, or this is basically mean question scores per app. So remember the feedback form that has been asked. So this is for binary things. So on the x-axis, it's what percent of people responded with a yes for an app, and the y-axis, it's like what was the number of such people. Okay, so across apps, it was found that most apps did not show a lot of ads. So if you look at it, most apps basically, so each of those curves is for ads. Did the app showed ads? Did the app crash? Did the app show a login screen? And finally, sort of, tried means, did the users try this app before? Okay. So as it looks like, the users have tried most apps before. So, there were very few people who basically said that they have not tried these apps, right? In fact, 0% people who said that they have not tried apps 75% of the times, right? So, and a few apps basically also show ads, and a few apps did crash, but majority of the apps, if you look at the area under the curve of this particular curve, 80% or so apps don't face all of those issues. Right. So here they also asked people a question as to, did you find playing around fun, and was the game's speed enough for you to interact nicely with it? Right. So just to figure out if CHIMP is working fine or not when relaying the thing from the virtual mobile phone onto the browser. Okay. So this was from a range of 1 to 3. So users could mark it as 1, 2, or 3. And they actually found that yes, on average, a lot of people did find it was fun and the speed was okay. Okay. Lastly, this is a CDF of actions, clicks and moves per user. So this basically just shows that about 10% of these inactive users, that is users with neither clicks nor movement. So here there are a few users who don't do any clicks or movements, but majority of the users, did a whole bunch of actions. In fact, there were some users who actually did 10,000 actions also in a session. Now that's actually quite a lot, right? But if you count the move, move is a very quick action, so that is actually possible, right? So that's that. So only 10% were inactive users, but otherwise users did interact with the app nicely. So this one basically shows that the code coverage metrics. So for most of the apps, the code coverage for all the 3 things was more or less, so each curve is for human testing, monkey testing, or combined testing, when some monkeys and some humans were used to test the app. Okay. And what it shows is that humans performed well in regards to code coverage compared to monkeys. So monkeys is basically blue line, and humans is green line. And as you see, humans and monkeys more or less they worked fine. And the code coverage is better when the effort was combined in that senses. Right? What this one further shows is that although the code coverage was more or less similar, in some sense, if you take a look at it, there's not much of a difference here. But what this chart actually shows across different types of apps is that the code which was covered by humans and the code which was covered by monkeys is quite disjoint, in the sense that using the combination, so Jacquard similarity, individual humans and monkeys covered code tend to be quite different, right? With a similarity lower than 0.5 for 59% of the categories. So a lot of categories, the code covered by humans and monkeys was very different, which basically means that using both for doing app testing is actually a great idea. Okay. Okay, lastly, let me just summarize what we have learned by reading this paper. So we now know a system called CHIMP, which can actually be used for mobile app testing. Described in detail how the entire system works. So virtual phone environment via which users can interact with Android from their browser, as well as experimentation platform and data collection modules and so on. Right. CHIMP achieves its scale by integrating paid worker services from Crowdflower, and CHIMP successfully leverages the wisdom of the crowd. Its users outperform monkeys for over 60% of tested app categories, right? About 59% tested app categories. And all CHIMP shows both the feasibility and applicability of keeping humans in the loop while doing mobile app testing. Okay, that's all. So that's all for this video. If you are interested in reading up the paper, go ahead, read the paper, and these are same references from the paper as well. Okay, that's all.